Now let's see how we make variable length arrays, or what C defines as variable length arrays. The size doesn't change, which is kind of what the name indicates. But it's basically declaring arrays from using a variable, right? A non-constant expression. Right? So we use a non-constant expression at program runtime. That means while the program's running, to determine array size. Meaning at startup time, the program doesn't know what size it will be. We haven't used a constant to complete it. Right. The advantage is a programmer doesn't have to choose an arbitrary array length, right? But as we saw in another example, you've seen another video, I just accidentally tried to initialize an array that had a variable length, right? And we could do that with multi-dimensional arrays. We'll just actually work on it with 1D arrays, right? We always start at the beginning, right? So a variable length array, use a non-constant integer expression. Still has to be an integer expression for the size. It just means we use whatever number is stored in some variable to determine array size, right? You can actually use a mathematical expression. So if we had x and y, we could declare an array that's of size x plus y, right? Or use a variable stored in memory as well, right? So I said the array length is computed when the program is actually executed, not when it's compiled. Right? Let's take a look at this example. So at compile time, notice I've declared array size here. We don't know what's stored in there. There's any kind of garbage stored in there. So we have the user enter the array size, and then we go ahead and store it in the variable. Then we declare the array size down here. We declare the array using the array size. Right. So I ask here, is this a good program? What happens if scanf fails to read in the data? Right, let's just go ahead and actually run this example. Spend a little bit of time with it. All right, don't need to return zeros. All right, let me build this. Okay, I've just got a bunch of warnings about ISOC. Yeah. All right. Oh, here. Copy paste got me in trouble. Let's try this again. There we go. Can't have two mains. It's warning me about not using my array. That's all right. All right. So let's do run the cursor here. All right. So we can see we've got some garbage in array size. It's got a pointer location for the symbolic name my array, but it really hasn't allocated memory. Let me delete this. This is from a previous example. All right, that's not part of our example here. Let's go ahead and run this now. So next line, right? And now, right, our program is waiting for us to enter something. So if I say 12, we come down here. Now array size is populated with 12. Now we'll declare the array. So we do this, then it did allocate memory for it. We don't have a way of seeing that right now in the debugger, but it did declare this. So in this instance, right, we are waiting on the user to input this value of array size. Previous to this, we have been declaring all our variables at the start of a program. Let me stop the debugger, right? If I were to cut this out and to move this up here, this is a bad thing because I don't know what array size is here. I use whatever garbage. So when you declare variable length arrays, right, you can't actually declare them until after you know what the value is in there. So in this case, we don't want to declare all of our variables at the top of a program. We have to wait until we get a valid size here, right, and store that. Then declare that. Store the value in here and then declare this with this array size. Now I asked, is this a good program? Well, let's build and run again. All right, so this pops up here. Well, what happens if I type -5? Do we like array elements with -5? Oh, sorry. So he didn't like that. All right, didn't even want to finish. All right. So we probably want to protect against something like that. Right? We might want to use something like if array size is less than 0, well, even 0, probably less than or equal to 0. We don't want it to be empty, right? Then we'll just go ahead and say if. Let's give an error message, error, array size entered. Let's just show that. Right. And then we'll just end the program. Right. And return -1. Right. So now if we were to do this, let's build. Now we've got some error checking in here. If I say -5, right, we see that message pop up, right? Error array size entered -5, program terminating. Our program returns from main. This never executes. So we never try to create an array with a negative size. Right. Other thing being, what happens if scanf fails? Right? What if I type in then something at the command line? Sorry. On the keyboard here. Right? What if I just type in the capital letter R? Right? It really doesn't know what to do. Scanf is actually failing. My cursor's sitting here. Right? My program just doesn't even know what to do. Right? I actually popped up on the other screen. I got a message saying this isn't working. It stopped working. Oh, I'm trying to cancel. All right. So I'm trying to get this over here. I got a message like this. I'm going to close the program. All right. I did something I didn't want to do. All right. A couple ways we can get around that. We could just go ahead and set a default size here of 1. So if scanf fails to read anything in, all right, so let's just go run the cursor. All right. Now, if I just type that capital letter R, right, down here we can see that array size happens to be 1. It will use our default initialization here of array size, and we won't try to create something with total garbage. Now, we still don't know that that happened. Right? Chances are what we really want to do is check the return value of scanf. Okay. Let's create a variable, then say int right, R value. Let's capture that R value. We could say if right, rval is less than 1, meaning scanf failed to read in a number, right? And we can say printf scanf error program ending, and let's make an error code. Let's make some error codes. You can say pound define scanf error. Maybe we'll make that -2. So maybe rather than -2, we'll just say return scanf error. Maybe we'll make another one pound define and call that range error. And maybe that will be our -1. Let's change this here to range error. Right. Really doesn't make that much difference what we return. We don't have another program picking up the values, but sometimes it comes in handy to start creating some mnemonics here for the error so that when we read our program, we have different values that we're returning. It'll probably become more important when we start writing functions and need to return information from functions. Right. So that would deal then with that being bad input on scanf. Let's build and run this. So now in this case, right, there's our capital R. Right, we just get this message, scanf error, program ending, right? Process return -2. Well, our -2 is that scanf error, right? So that way we didn't go on with the default size. Now how we want this to behave is kind of up to us as programmers, right? If we're writing this for a customer, we might ask the customer how we want it to behave. We might have other modules this needs to interface with other functions, and we know better how to make it behave. What if we said we wanted to go on with some sort of default value whenever scanf failed? Right? What we could do is then we could then create maybe another macro. Let's call this default a size. And now we could say, we could just set this equal to default array size. Right? When this fails, instead of ending, we could just, we could print out a message, right? But we could maybe not leave. We could say scanf error, something like using default array size, right? And it could go on then and run whatever code we want to run. In this case, it would declare an array of that size. So let's do run to cursor. Oh, I forgot to give that a size. And I forgot a semicolon. I don't. Some days I wonder if I've ever coded before. All right. So now let's take a look at what happens. All right, run to cursor. Pops up. I type my capital letter R, hit enter. You can see scanf returned to 0. This function then returns 0 because it failed to read anything and store it in array size because it can't handle a character when it's expecting an integer. Now it'll come in and it'll print out our error message, so there's that, but still it goes on, right? It recovered in this case if we decided that was acceptable behavior. Right, it would still check the range in this case, which it should pass with our default array size, right? And then we can come down and hopefully safely create that variable length array. Right, so some different things we could do there just to handle those errors or those different situations. Right. So we can't use an initializer list. I think that was in the slide. Right, so if I were to put something in here like this, like now that I'm creating it, well, let's just fill it to all zeros. Let's see if the compiler likes this. Now, see what the compiler says. Error variable size object may not be initialized. So we can't use the initializer list, right, when we use a variable length array. All right, that was that example. Now, here's something else we could do in terms of scanf. I was using the return statement. There's also an exit function we can call. If we use the exit function, it's defined in the standard library. So rather than return, we can code exit. We can pass it this macro that's already defined in there. So exit failure is already defined in this library. So this will terminate the calling process. Well, in this case, this will actually terminate main if we were to do this. So let's see what happens if we were to code in that exit failure and change our example. Or let's just run this particular example here. Okay. So build and run. I want to make scanf fail. So here I'm actually then checking scanf inside the if condition. Right, instead of storing in a variable called return value, I'm just using the value that it returns to compare to 0 here. All right, so I'm going to type that capital R, hit the enter key. We know that fails. So that returns 0. 0 is equal to 0. Right. And it printed out our message, and then it uses function exit failure, right, to indicate then there was a failure And in this case, exit failure, that mnemonic happened to be the number 1. So as we start learning to write functions, if those functions fail and we need to leave the program, right, we'll see that using exit will stop the process. And the process is the actual running program, right? We won't even have to go back to main. We'll talk about that when we get to functions. All right, so that's it for variable length arrays. The important part is, remember, you don't declare the array until you have a valid number stored in the size variable.